All right, hello everybody. My name is Braeden Waters. I'm the VP of Sales and Marketing for CGIS. We're excited to be able to share some of our knowledge and experience with you today. Today's session will focus on molecular sieves and the valves that are often used and the valves that we feel maybe should be used for these applications. We'll focus primarily on mole sieves in gas systems, although Kev will take us through a couple of the other applications there. At CGIS, we continue to aim to be the leaders in severe service valves. Over the past few decades, we've seen a number of plants, we've seen the need for plants to operate more efficiently, to be competitive. I think our focus on severe service valves over the past 40 years have taught us that not all valves are created equally. And what maybe worked 20 years ago may not give the plants the life, the reliability, or the safety that's required in today's competitive landscape. At CGIS, we often challenge convention, find new innovative ways to attack these increasingly difficult applications. Today, Kevin's gonna bring us through one of these cases, in particular with the mole sieves. But first, with some housekeeping. We like to keep this interactive. Our knowledge definitely increases through the lessons learned, both from our clients and our vendors. So we like to work closely with you guys. Please feel free to ask questions. In the bottom left, there's a Q&A box that you can click on, and we'll be monitoring that throughout the session today. We'll try to get to them at the end of our best time allows us, and if we can, we'll make sure that we can follow up with you guys after the fact. Next slide. So to take us through today's presentation, we have one of our most experienced technical sales reps, Kevin Niebergall. Kevin resides in our Prince George office. He's been with CGIS for over 25 years. He's our resident expert in pulp and paper, oil and gas, and LNG. In addition to assisting numerous clients with valve solutions over the years, Kevin has begun to share his experience with the market by publishing a number of articles in industrial magazines, especially around the LNG marketplace. So I'm going to stop talking and pass it over to Kevin, who will take us through today's presentation.
Thank you very much, Braeden. Thank you everyone for joining us today. I see some familiar names and some new names, so it's great to have you all with us today. I wanted to start off with a safety moment. We're all very familiar with COVID-19. Some of the requirements have changed over the last number of months. But something I've noticed in public is people wearing masks that are only covering their mouth, not covering their nose, and it's critical that the mask covers both your nose and your mouth to protect those around you. The other point that I wanted to talk about was loss of smell and taste as we move into the flu season. We're going to be experiencing many of the same symptoms that we would have between COVID and our normal flu season effects. But one of the key criteria or symptoms with COVID is losing your sense of smell or taste. I also wanted to shout out to all of my clients through the 20 years or 25 years that I've worked with that's helped build my knowledge of process and business needs for their requirements and helping me develop the experience and knowledge that I'm here to share with you today. And as said, thanks for joining us. So what is a molecular sieve? It can be a two-tower system or multi-tower system. It can be bulbs, a variety of vessels used to filter media, contaminants out of media. So as a process diagram, this is a basic two-tower system. We have an absorption phase and we have a regeneration phase. So to regenerate the molecular sieve itself, the beads to dry out or drive off the contaminants that have been collected through the absorption stage. And in between these, we have switching valves for regeneration purposes and for absorption purposes. In the true sense of the word, molecular sieves are also dehydrators. We also refer to them as dehydration units. Molecular sieves, when you get into some of the pharmaceutical or chemical industries will then generate or select their openings or the pore size of the bead in order to focus on certain contaminants that may be in the flow stream. So we see molecular sieves in obviously the natural gas industry, in the oil industry, along with chemical, pharmaceutical processing as well. So what I've learned through the years is requirements for successful valve performance is durability, having reliable isolation that is repeatable, and reliable operation are keys to having a well-functioning molecular sieve or dehydration system to ensure the most efficient use. So in the application, we run into various challenges. In the natural gas industry, obviously H2S, CO2, chlorides, any liquids, entrained solids, and with these conditions, we have a potential for corrosion or corrosive chemicals being generated within the flow stream. So material selection is based on what we're presented with in the application. So determining levels of or percentages of H2S and CO2 and other components are important for us with material selection. Application challenges with the temperature. We're swinging from 40 degrees Celsius to 350 Celsius to regenerate the tower. So it's an extreme differential. And one thing that we have to be thinking about with valves is looking at what materials, how the valve is designed, and how they expand and contract at different rates. And what can we do with the product or the design to withstand these conditions and provide you reliable isolation and reliable operation. Solids. There's a wide range of solids that we can be presented with in molecular sieves. The beads themselves can dust, particularly when they were replaced and brand new. The beads are just replaced or brand new in the system. They'll have more and more dust presented to the valve or to the process system. Another thing, black sand can be generated through the piping systems and flow through to the valves. So it's an abrasive component. And then as we develop more into the shale gas, we see more and more sand coming through the process. So typical valve issues, valves are seizing, they're not isolating well enough, so the regeneration or the absorption is thrown off its goal or its set point. Large automation assemblies taking up a lot of space within a building or in the area. Regular repair, and then the cost of replacement parts or new valves, and product delivery times. We're seeing and hearing more about the longer and lead times over the last number of years. So going into the typical valves that have been used or that we've seen in the field, one design is a trunnion-mounted ball valve. Some of the limitations of a trunnion-mounted ball valve are its lower hub that you can see in the lower circle there. With the fines or the particulate that are entrained within the gas stream, they can find their way into that lower trunnion, and that can cause seizures or stiction where the valve sticks as it opens and closes. And with a trunnion-mounted seat design, we have seats being pushed onto the ball. So our ball is in a constant static position. But it relies on springs and pressure within the piping system or within the cavity of the valve to seat. And we do see solids build up in those springs that cause them not to operate efficiently or effectively. So these are some of the limitations on a trunnion-mounted ball valve. This is the most common design. a rising stem ball valve. And in this particular case, we have a guide pin and a groove that rotates that stem as it moves. This is a linear to rotary valve. So as it is opening and closing, the stem is moving up and being rotated by the guide pins. And then it has a helix to connect the stem to the ball. And what happens with this design is it actually tilts away from the seat, or it cams away from the seat as it operates, which is a positive thing in terms of lower friction, and the theory is that it reduces the wear, but what we've seen in services is not holding true to that. It also has a lower trunnion where media can again build up and cause valve operation issues. So some of the headaches with the rising stem valves is debris can be pinched between the ball and seat. As you can see, there's a space between the ball and the seat as the valve is operating, and that'll allow the media to flow through there and potentially be pinched as the valve closes as it cams back into the seat. We can also see vibration issues if we're flowing really high volumes of gas. It can cause a vibration, which can cause some mechanical machining. So these are some examples of what we've seen in the field of wear and tear on these components. In the photo on the left, we can see that there's been some galling, some scoring caused as the valve starts to rotate. And also you can see a fine ring right about here as it's being pushed into the seat. On the right, this is the stem guide, and it's been marred or deformed by the pins, which is going to cause some operational issues or possibly even have the valve jam in one position or another. On the right-hand side in the circled area, this is where debris has been caught between the ball and the seat as it closes, and it's damaged or caused a damage the seat itself. On the left, we're seeing signs of the camming action or the pressing action of the ball into the seat, and it's causing wear on that seat, which then leads to leakage issues and causing the regen cycle or the absorption cycle not to perform efficiently. In larger sizes, typically those above 12-inch, we do see high-performance butterfly valves, and the economy of the valve is quite often the reason it's chosen, and even the size and weight of the valve. But what the limitations here is, again, we still have a lower hub or a lower stem area where media can build up and cause operational issues. As the valve cycles and open and closed, we can see some flow issues through the valve and at the seat area that affects its ability to isolate. On the lower left, I've circled the disc area because the disc, when it's open, creates an obstruction, so that'll affect our flow. But more importantly, the sealing surface is exposed to flow. And if we have solids or particulate, we can cause wear to that edge, which affects our ability to isolate. So this is computer, it's a model on a butterfly valve disc opening and closing, and we can see what the velocities are as the valve is opening and closing until it's into its full open position. It's causing turbulence and high velocities in certain areas of the valve body itself. So things to be looking for, obviously linear to rotary function, that mechanical mechanism, how durable is it, what would be the service life of that, how many times is the valve opening and closing within a set period of time. We do see Some valves cycling more often than others in molecular sieve or dehydration. When we look at PSAs, there's a lot more cycling occurring in those valves. So the mechanisms that are used to cycle that valve open and close it require our attention. Areas where you have cavities or pockets become a collection area for some of these solids, the entrained solids or dust that is present in the gas stream. Preventative maintenance, what are the requirements for the preventative maintenance program? Do we have to grease the valves? Do we have to lubricate the valves, etc.? And isolation performance, which we'll get to a little bit further in. But one thing I do want to say about Class 5 and Class 6, Class 5 is for metal-seated valves. It has an allowable leakage rate. Class 6 is for soft-seated valves. It also has an allowable leakage rate. And if we have a little bit of leakage, it's going to get worse over time, particularly in high differential pressure conditions. Temperature cycling, the way the valve operates and the various components, how do they contend with the temperature? Especially with a 300°C swing, things are going to be moving in, as mentioned, at much different rates. And then the flow, looking for something that has unobstructed porting, like a ball valve, gives you a higher flow, lower pressure drop, and higher CV, obviously. So we said that we had some Tylenol for molecular sieve headaches, and in the 80s, a new ball valve category was created called seat-supported ball valves. The ball is being aligned or held in place by two seats with a bell valve spring. And with that, it's always in contact with the seat. It doesn't allow particles to become pinched or trapped between the ball and seat as the valve opens and closes. And everything can move independently with temperature. So the bell valve spring has a preload that presses the ball into the downstream seat, which is integral to the body. And in having an integral seat in the body of the valve, we've eliminated one of the two potential leak paths in a ball valve. As we can see with the upstream seat, there's a space between the ball and seat. So potentially you can have leakage in behind the seat or between the ball and the seat. So those are our two potential leak paths in a ball valve. With an integral seat, we've eliminated the in behind the seat potential flow leak. And in utilizing the bell valve spring and the upstream seat, we're able to press that into the ball, or into the seat, sorry, and ensure it's always in contact. In addition, with this seat-supported valve design, we have live-loaded packing. The packing is die-formed graphfoil with anti-extrusion mesh rings, top and bottom. And they are in the live loading is energized with 6 bell valve springs in 3 sets of 2 opposing each other, so that we have constant energy on the packing gland and the packing itself to provide us with zero leakage through the packing area. So when we start talking about metal-seated valves, we need to realize that metal-seated valves are not created equally. There's a variety of different coatings that are utilized by manufacturers. We have to quite often use dissimilar metals in order to ensure that we don't have any cold welding or galling or marrying. But with hard coatings, we can now look at thermal sprays using tungsten carbide or chrome carbide, start off with a very high hardness and maintain that at elevated temperatures. So we can see with stellite, we lose our hardness as the temperature ramps up, and that also holds true for electroless nickel plating. though ENP does start off harder than stellite, but it still does suffer from temperature effects and softening and losing its hardness. So RITEC is robotic integrated technology, and the HVOF coating is applied by a D gun or a detonator gun. It's propelling chrome carbide, melted chrome carbide or tungsten carbide particles at a velocity of Mach 3. And one of the keys, as you can see, one of the benefits of robot technology is that we're able to maintain the impact zone as close to 90 degrees on an orbital surface so that we create a high energy impact, and that creates a high bond strength of the coating to the ball, or the substrate, I should say. So it's greater than 14,000 PSI. We can only say that it's greater because the tests start to, well, there's nothing that's been able to exceed that measurement. Another point about HVOF or thermal spray is there's a variety of different fuels that you can use to create the flame or the burn or the energy for applying the chrome carbide or tungsten carbide. You can use kerosene, butane. The drawback to some of those fuels is that they leave a residue in the coating, which affects its strength. So with valve technologies, we use hydrogen, and it's the cleanest burning fuel. So we have the least amount of residue left in the coating itself. And to be able to provide zero leakage in a metal seated ball valve, there's three processes. There's a rough lap, a mate lap, and then a final mate lap. And we're using diamond paste to make an exact surface match between the ball and the seat. And you can see in the lower left-hand corner image, the mirror-like surface that is a result of the lapping process, so that we have an extremely fine, smooth surface area for between the ball and the seat. And I should mention that the hard coating is also applied to the seat itself as well. So we have chrome carbide on chrome carbide or tungsten carbide on tungsten carbide, and all are mate lapped for that zero leakage performance. The surfaces end up being so smooth that they develop surface adhesion. So they will actually stick together, which is something you don't want to be playing around with when you have a coffee mug sitting on the table across from your customer. I unfortunately ran into that the hard way. So the market growth for seat-supported ball valves, the first valve was supplied in the early millennium in northern British Columbia. It was the first application of a seat-supported ball valve that I'm aware of, that most of us are aware of, for molecular sieve or dehydration application. We've now supplied these across the country in Alberta, British Columbia, Ontario, and from there we've gone on to projects in Kazakhstan and also in the Middle East. So this is a case study that we're lucky to receive from Terry Hugenboom, who's the operation leader. He's standing beside the very first valve that we installed in 2003. We had introduced the product to them in 2002. They were frustrated with regular annual repairs on their molecular switching valves. And so after showing and reviewing the application with them, because it was our very first time in doing this type of application, we we committed to a performance guarantee, and the requirements was that the valve would last at least 2 years, if not longer. And that was based on the acquisition cost of the valve. We were roughly double the price of our competitor. And after 2 years in service, the valve was removed from line. It was disassembled, and it was in perfect condition. There was no scoring, there was no leakage issues. So as a result, they started replacing the rest of their valves on a regular, and in some cases, a complete replacement. So the problems that we were presented with here, high levels of H2S, anywhere from 28 to 30% H2S. We had about 12% CO2. The chlorides were between 65 and 75,000 parts per million, and we had about 10% water in the process. So there was potential for generating carbonic acid and sulfuric acid in this application. So as a result of the high H2S content, we needed, and the resulting partial gas pressure, we need to select Hastelloy C276 for the ball and stem. So in certain high sour, high chloride applications, because of the seat supported design, we have to use a full ball made of an exotic alloy and a solid stem. The maintenance issues that they were presenting with is every 12 to 18 months, they needed to repair the valves or replace the valves. And during normal operations, the valves would jam and seize on them. This first location was an unmanned location, and it was about an hour, 2-hour drive from the nearest town. And so it was unmanned during the night, so they'd have to wake somebody up and drive out there to switch or get the valves to open or close. And then they were dealing with longer lead times. So our solution was the Valve Technologies V11, which is their high pressure valve. It's a zero leakage isolation valve. The first valve was, after completing its performance guarantee, it ran for another 6.5 years before it was needed to be replaced. And the reason that it needed to, the corrosion that had occurred inside the valve was starting to eat away at the integral seat. We offered to go to a higher alloy body, and after the 8.5 years of service, they were tickled pink. They did not need to worry about, they were happy with that kind of lifespan. So the choice was made not to go with a higher alloy, just to stick with the A105N that we'd initially installed. So for us, this case study, the cost of ownership and the return on investment you can see is significant. Over that time frame of the 8 years, they realized a $4 million benefit, or a $4 million benefit due to less downtime and fewer valve replacements or repairs. In fact, the valve was never repaired during its service life. So we were able to improve the process efficiency because of the isolation performance that far exceeded the competitor's product, and as a result, provided a significant ROI over the lifespan of the valve. CNRL Dunvegan Gas Plant in northwestern British Columbia, or sorry, Alberta. We've installed valves on their acid gas dehydration units. Again, they were experiencing the same type of issues as was ConocoPhillips. Service life of 6 to 18 months. They would see leakage anywhere from 3 to 6 months, and then they would have to do maintenance annually on these valves. Again, they were running into the exact same issue of valves jamming, having isolation issues, the long lead time for parts, and the associated cost with that. In that particular case, the V12, which is a low pressure valve from Valve Technologies, we're now seeing 8 to 10 years of service life on the acid gas application compared to our competitor of 6 to 18 months. So again, significant return on investment and better operational efficiencies has been achieved. So with the Valve Technologies product line, 1/4 inch through 36 inch, wide range of pressure classes, can handle significant temperatures, can actually go down to -196 because we do use it in liquid natural gas or cryogenic applications. We have integral seat, which leads to its isolation performance. True quarter turn, and so the packing, the stem is always turning within the packing, whereas in a rising stem design, the stem is moving up and down through the packing, and any particulate or any type of pitting corrosion that occurs with the stem is then pulled through the packing and causes leakage. So with a true quarter turn design, the stem is staying in a static position basically and turning within the packing so that there's no debris that's being introduced between the packing and the stem itself. They are zero leakage. Valve Technologies valves are tested according to ASME or API or ISO standards in the soft seat categories. And in addition to that, they have their internal quality program for testing, which is a 3-minute long nitrogen test at a low pressure. So in class 900 valve and higher, they're all tested at 100 PSI, and then maximum differential pressures as well, which at 110% of it. So, and then a wide range of materials and just the overall, the overall longevity of the valve is one of the major advantages in the design.
I think I've just to interrupt, there's a question that came up that may be pertinent to this point here. Any maintenance that can be done to refurbish the Valve Technologies, or does it require complete changeover? Okay.
So we can do kiss lapping with the ball and the seat. So that, and if we were to see, you can actually lap this valve while it's in line simply by cycling it 10 to 20 times. Because we're into metals that burnish, it will relap itself while it's being cycled in line. If that's not successful, then we can kiss lap it. So we're essentially just running another lapping process for the valve. But if it is beyond, if the coating has worn so much that it's not isolating and kiss lapping is not successful, then we would need to, we can blow it off or blast it off, but typically we'd have to replace the ball and seat as a set. And then packing is really straightforward. We can replace the packing in the valve. We can replace the loose upstream seats or the bell valve spring. But if in case the coating has worn to such an extent that it's not repairable, then we'd have to replace the ball and the seat.
Just to mention too, we can, CGIS can help with that. Either we've done some of that kiss lapping at site, or our facilities across Canada can definitely help with the repair on that as well. Mm-hmm. Thanks, Kev.
You bet. So the one of the main focuses we have is looking at applications, and we believe that the application dictates the valve selection. And there's a lot of good valves that go into certain applications where they're not successful, not for a fault of the valve, but because of the application. So there's a number of different things to be considering when selecting the valves that is part of our everyday being at CGIS. So we take a cost of ownership approach, total cost approach. So what is the valve cost initially? What's the cost of the actuation or the automation of the valve? And then of course there's the installation costs, life cycle costs caused by maintenance, repair, replacement, and loss efficiency, wear and tear. So the material selection and effects on the durability or the longevity of the product itself. So here's photos of valves that we have in northern BC. On the left, this is the Boulder plant by CNRL. Those are the 3-inch class 900 regeneration switching valves that were installed in about 2004, 2005. They're still in service today. On the right is a 6-inch class 1500 absorption switching valve with a facility near Chetwynd, British Columbia. It started off as a shell facility. The unique thing about these is they actually have hub connectors instead of flanges. Class 1500 ocean engineering hub connectors. And with the automation, we have a declutchable gear override on it, along with the Scotch yoke actuator. So that pretty much wraps it up. Any questions for anybody, or?
One question came on earlier, Kev. Can you speak to the material that was used for the acid gas applications?
Certainly, yeah. Sorry, and I missed that earlier. In the acid gas application, we have just carbon steel with 4130 chromoly ball and stem, and then chrome carbide coatings. So as we looked at that graph on the cost of ownership for the first application, we were twice the price of a rising stem ball valve. In the acid gas applications or the propane butane applications, we are virtually the same as the majority of rising stem ball valves. We're within 5 or 10%. The significant difference here was because of the Hastelloy C276 ball and stem. But in acid gas, propane, butane, we can use standard generic materials per se of chromoly and carbon steel.
Just had another question come in. Great presentation. Will you be making this available to the attendees? Yes, Sam will be sending out a copy of the recording, and we can definitely get you a PDF of the slides as well. Thanks for that. What is the class of the valve? Zero leakage as per which standard? So 2 questions there. What class? Yeah.
Okay. So zero leakage is according to either API 598 in the soft seat category or ISO 5208 rate A. And as stated, the additional testing that Valve Technologies applies does it at a low pressure and at the maximum pressure rating of the valve class. So 110% of that valve pressure class, which is a unique point to be making is majority of valves when tested are only tested at 110% of their valve pressure rating. So if it's a class 600 valve that's rated to 1480 PSI, at the factory it's being tested to roughly 1750 PSI. So it has a lot of energy in a ball or in a ball valve where it's pressure assisted, being pushed into the seat, there's a lot of energy. We take that valve and we put it into a class 600 piping system where we're only running 900 or 1000 PSI or 5500 to 6000 kPa, and we don't generate the same energy. But when we go into molecular sieve applications or dehydration applications, now we're dealing with a very low differential of pressure, typically less than 10 PSI or 15 kPa. And so we don't have the same energy being generated by the piping system to create energy and load on the ball and the seating system. So having a valve that doesn't rely on pressure, such as the Valve Technologies design, is key. So it doesn't care if you got 1 PSI on it or 1000 PSI on it. It's going to perform as a zero leakage isolation valve. And So with the VQP010, which is Valve Technologies Quality Procedure 10 for testing their seats, for that duration, they're actually in a soft seat valve, they're probably, or sorry, in a metal seated valve, say a 3-inch, it's typically, according to API 598, would be tested for 15 seconds or 30 seconds. We're testing it for 3 minutes. So it's a more stringent test, and it's done at a low pressure and a high pressure. So it's simulating the process conditions. But as said, ISO 5208 Rate A or API 598 in their soft seat category, where there's no allowable leakage when tested.
Yeah, and great answer, Kevin. I think one thing just to make really clear, because this often gets confused, and if anybody's interested, we actually did a webinar for those who missed it a couple of weeks ago on seat leakage standards in the industry. Definitely send it out to everybody. But with the valve technologies in particular, they are throughout the full lineup of valves. They're metal seated valves. An API 598, as Kevin mentioned, they have a soft seated version and a metal seated seat version test. And despite the fact that valve technologies are metal seated, they test to and meet the resilient seat standard, which is at zero leakage. So there. And then the other part of that question, Kevin, was what is the class of the valves? So Valve Technologies, quickly answer that. Valve Technologies makes class 150 up to class 4500. We normally see class 600, class 900, and class 1500, Kev, in most sieves in the gas industry.
Class 300 to class 1500. Class 300 for the acid gas system at Dunvegan, class 300 at Pembina's facility in Taylor, which is a propane natural gas liquids facility. And then in these cases here, these valves that we're looking at are in the gathering, on the gathering side or the upstream side, where they're running higher pressures.
Yeah, and in Valve Technologies world, they consider their low pressure valves class 150, 300, and 600. And then they jump up to the class, the high pressure valves, which are class 900 and above. So the V11 series would be their high pressure forged bodies, and their the V12 are the low pressure valves. Okay, another question came in. Replacement of ball and seat can be made on site? Question mark. How easy is it? So, you want to see that?
When we look at the Valve Technologies design, it is a two-piece body. There is a stack height. It's certainly possible to repair it at site. I would recommend that one of our technicians is deployed to assist with it, because ensuring that the seat stack or the spring stack is in the proper tolerance or height is critical to its performance and its longevity. So having assistance with that is recommended, but we have done on-site valve repairs in the past. One lesson we learned through an application on a mole sieve was we were using thermal sprays as the stem coating, and 1 in a million chance you can have a porosity chain in a thermal spray, which we did experience. And so we did a stem replacement at site in the middle of winter with a boron nitride fused coating on the stem to ensure that there's no potential for a porosity chain development. And so we replaced the packing, the stem, and rebuilt the valve at site. So definitely doable.
All right, few more questions here. Distributors in Eastern Canada and Quebec, so I could happy to answer that one. Yes, so we're happy to announce that as of a year ago, CGIS was granted the distribution rights across Canada. So we've expanded into Eastern Canada fairly significantly in the last year and a bit. So we partnered up with a valve repair facility called DHP out of Quebec. And we have 3 of our sales team that sits out of that office. So we partner with them for valve repair, and then our team looks after new installs. So I could definitely get you some contacts there. And then we've recently opened up an office in Ontario there, where we've also been starting to sell. We got our first order for mobile sieve applications a couple of months ago, I think.
January for the Enbridge for the Dawn Hub. Yeah.
That's a good question. Thanks for that. And then follow-up question on that one is, what would you use for Class 600 benzene service?
Sorry, can you repeat that?
Class 600 benzene service. Insight into that? If not, we could probably maybe take that offline and get back. But
yeah, we could definitely. We can select a valve for it, and Valve Technologies would definitely work for the benzene service as well.
Okay, but we'll definitely follow up on that one for you and get you some answers.
One of the a number of years ago, we as a company with recognizing data sheets don't always provide us with the information we need. We modified the ISA control valve data sheet, added in some fields for isolation performance and cleaning, and a number of different fields, about an additional 8 or 10 lines that help us in making a valve selection. So we modified the IV, and we call it the IVSF. It's an isolation valve specification form. We can supply that to you to determine what are the temperatures, what are the pressures, how often the valve cycles, things along that nature that help us or aid us in selecting or recommending a valve product. And what we have to keep in mind is a lot of data sheets are static. It's a shot in time. There's dynamic issues that affect valve performance. Probably the best example I have of that is for blowdown applications where we have 6,000, 7,000 kPa, and we're dropping that to atmospheric pressures as we blow down a system. And that initial opening of the valve, as we saw with the butterfly valve CFD modeling, there's an extremely high velocity at that initial point of opening. So that cracking velocity can damage seats, balls, downstream piping components, not to mention create a lot of vibration that can affect other components of the piping system itself. But there's a dynamic phase as the valve opens and closes. So that's something that we always have to keep in mind.
Yeah, very good point. All right. Comment, and here is a super presentation. Thank you. The case study, success study material is very informative and would with further examples be available for discussion to support clients' proposals. So absolutely, I think we presented 2 here. Kev's, like I said, we've sold over 100 of these across Canada to date, and many more opportunities to come. One of the things we do at CGIS is we tag the majority of our severe service valves and keep good records on them. Trying to separate ourselves from a commodity valve supplier, going after critical applications. We really want to learn from those from our installs. So we keep fairly decent records of where they've been installed and have good case studies there. So if there are anybody out there that would like some more of that, then please reach out and we can work with specific applications. Next question is, what is the approximate replacement cost in percentage for the ball and seat versus a new valve? Okay, off the top of your head. If not, we can wager.
I think it's roughly 50%.
Yeah, that's what I was going to say, 50, yeah.
Yeah, it depends on materials, it depends on size and pressure class, but as a general rule, I would estimate 50%.
Mm-hmm. Yeah, I think these valves for us, not only do they operate in the oil and gas sector and in most sieve applications, we have valve technologies in mining applications, in power indication applications on steam, and we haven't done a great job of going after the customers and and helping them with repair. It's sort of, we've been a bit more reactive, and because they last so long, there's not a ton of cases where they are, but there are a few applications that we do get some, and customers do send them back and we do repair them. It's financially makes sense for them to do that. So yeah, we can, we'll verify that. If we're off, we'll follow up with that, but I think that's probably about right. Another good question, suitable for high cycle applications, 30 operations per day. Does that sound doable? Yeah, but I don't know if that's that.
Yes, yeah, it's definitely doable. We do in certain applications select the high cycle top works. So we have proper alignment control of the stem itself and then have bushings and bearings that allow us to go higher than 30 cycles a day. But 30 a day is definitely doable. I think we can probably take 100 a day and then be successful with it. They have done a number of high cycle applications in the in North America, and continue to be able to provide like fugitive emissions, zero leakage protection. So yeah, definitely doable.
You know, just to add to that, I think there's a couple things that you want to look at when you talk high cycle. It's not only the valve itself, but the mounting kit and the actuator and the whole package. One of the things that Valve Technologies takes very seriously when they engineer their valve is looking at that full package. And if you look at their mounting kit compared to others that maybe don't even consider that, it's very well engineered, very well designed, ensures that alignment in the stem and the transfer energy between the actuator and the valve itself. So all those things need to be taken into consideration in these severe service applications. The other big point that we touched on, and I don't know if we maybe we need to make it a bit more clear, when we look at the alternative, the rise and stem ball valve, you know, it was designed as a smart way to address a single problem, but in doing so, it's almost created another problem in that you're converting a rotary motion to a linear motion back to a rotary motion. So with all those changes in motion, it can cause problems and mechanical wear in different places. And so the simplicity of the quarter turn valve when it comes to the packing and fugitive emissions is it's so much simpler, and the simplicity is what leads to the longevity and the ability to hold the media within the process and rather than out to atmosphere. And as Kevin said, that raising motion of a linear valve, any score, any damage to the packing is going to create that damage from the process out to atmosphere, whereas damage in a quarter turn valve is going to be within the plane of the packing itself. So the quarter turn ball valve, especially a well-designed one, is better suited for those high cycles. Excuse me. Good. Well, I think that looks like all the questions. So I just got a text from one of our very smart employees, and yes, in terms of high cycle applications, in some of the in one of the poly plants that we supply this valve, they've run into how many zeros? 1 million cycles a year, it looks like. All right. I believe that's right. Kev, can you comment on that?
Well, they're definitely, they have done million cycles in a year.
Correct.
I don't know how to speak specifically to it, but I know in talking with the people at Valve Technologies, they do talk about doing 1 million cycles a year.
Yeah. Again, you know, it's I think one of the things to really look at too is understanding that application. Kevin mentioned that, and you know, one of the things that we're looking at when we're you know, our president's working on defining severe service through MSS and recognizing that there's different types of valves, and even within the similar types of valves, there's different qualities, and valves are designed for different things. And so really understanding what the application requires and making sure you have the design that's going to be able to handle that is critical. And that's one thing that we do closely with the valve technologies and some of our other severe service valves. All right, perfect. So Kevin, maybe we can just advance a slide. I think our contact information should be coming up. Yeah, there it is. So thanks all for your questions. I really appreciate that. It always makes for a great presentation. If there is any other questions or any comments, please feel free to reach out to Kevin or myself. Our contact information is there. Otherwise, stay safe, and hope you learned some stuff, and stay tuned for some more of these presentations to come. Thanks all.
Thank you very much, everyone.